Okay, we are going to discuss another chapter, which is static equilibrium and elasticity. We are referencing Physics for Scientists and Engineers with Modern Physics by Survey and Jewett. Disclaimer: this video is intended as instructional medium for engineering students. This video can be downloaded for free at www.youtube.com. This video was uploaded on YouTube by the creator for audio-visual purpose during class discussion and/or online reference. This video is not regulated by the institution. Any use of this video other than its purpose is its viewers or users' responsibility. The creator warrants or allow the pre-use of this video only for instructional purpose and reference. Any use or abuse of this video other than its intended purpose is at user's responsibility. Learning objectives. At the end of this chapter, students will be able to learn analysis model of rigid objects in equilibrium, the center of gravity, examples of rigid objects in static equilibrium, and elastic properties of solid. Okay, nandito naman tayo, gawin nating Tagalog. I prefer to make this Tagalog. Sa PowerPoint ko na lang ginawa kasi medyo natatagalan ako dun sa ating mouse. Mouse lang kasi yung gamit-gamit ko sa PowerPoint. Tinatype ko na lang, nilalagyan ko na lang ng konting automation. Nung mga nakaraang chapters, pinag-aralan natin yung dynamics, rotational motion, circular motion. And nung preliminaries, tapos na rin tayo sa force, alam na rin natin yung pagkuha ng resultant, alam na rin natin yung torque, mga moment, and then napag-aralan na rin natin yung tungkol sa mga work, impulse, momentum, yan. And resolution of forces, lalong-lalo na yung mga projectile motion. So, meron na tayong dynamics, meron na rin tayong mga, yung Newton's laws of motion, meron tayong Newton's first law, which is the, ano nga ba yung Newton's first law? Inertia. Okay? A body at rest will remain at rest and the body in motion will remain in its uniform motion. Okay, unless it is acted upon by an unbalanced force. Kailangan daw yung mag-a-act sa kanya unbalanced. Otherwise, kung ang mag-a-act sa kanya ay balanced din, it will remain in equilibrium. Okay? So, meron din tayong second law. Ang sabi sa atin, yung force daw, the force is equal to MA, So, yung daw acceleration ay directly proportional to the force and inversely proportional to the mass. Okay. Ngayon, meron din tayong third law of motion, which is for every action, there is an equal and opposite reaction. Ngayon, bakit ko ba sinasabi itong lahat ng bagay nito? Kasi lahat ngayon, lahat ng napag-aralan natin from the start, ito na po yung application. Ang tawag po natin dito, statics. Okay, statics po ito. Bagamat hindi ko po sasakupin yung buong statics, introductional statics lang po tayo rito. magsosolve lang tayo ng mga concurrent coplanar forces, no? Kaya natin nire-review. Okay. So, in this chapter, i-address daw natin yung condition ng rigid objects. Alam din naman natin yung rigid object wherein ang isang bagay ay nagkakaroon ng solid na bagay ay manineglect natin yung kanyang tinatawag na deformation. Ano? So, that is a rigid object. So, ano ba yung equilibrium? Nung nasa prelims tayo, equilibrium, ito yung sinasabi. So, it came from a Latin word, equi, that means equal, and libra, that means balance. So, equilibrium arises if the vector sum of all forces acting upon the particle is equal to 0. So, yan. Yan yung tinatawag natin na equilibrium. Ngayon, napag-aralan din natin na, sir, ang equilibrium ba pag nakatigil lang? Hindi. Mayroong umaandar na nasa equilibrium. For as long as balance yung forces and it is in motion, kapag uniform yung motion, we can say that it can also be equilibrium. Kapag wala siyang acceleration, no? So the velocity is constant. In that case, 0 din po yung ating acceleration. So yan po yung ating key takeaways dito, no? We deal here only with the special case in which both the velocities are equal to 0. In which case, ang tawag natin is static equilibrium. Ayan. Yun daw hindi gumagalaw na equilibrium, ang tawag doon is static equilibrium. So, kapag walang motion. Okay, so yun yung pag-aaralan natin. Okay lang daw naman nasa static equilibrium ang isang bagay. Ang isang bagay daw ay maituturing natin na nasa static equilibrium if and only if tatlong bagay. Summation of forces in each direction is 0. So yung unang bagay, summation of forces at y is equal to 0. Summation of forces at x is equal to 0. And summation of torque or moment is equal to 0. Yan yung tinasabi natin 3 equations of static equilibrium. Okay. Pag-aralan naman natin ngayon kung ano yung coplanar forces na tinatawag na yan. Yung coplanar forces, coplanar, ibig sabihin, nasa isang plane. Coplanar nga eh. Kapag co-teacher, kasamahan mo doon sa school. Co-teacher. Co-planar, kasamahan mo sa plane. O, di ba? Ganun lang yun. Co-worker, kasamahan mo sa worker. Co-planar forces. For example, this is the plane. O yan yung mga forces acting. So, ang tawag dyan, coplanar. Ngayon, maraming klase yung coplanar forces. Ano? Maraming klase. Meron tayong unang tinatawag na concurrent forces. Ano ba yung concurrent forces? Coplanar force system is a system of two or more forces whose lines of action all intersect at common point. Kapag daw nag-i-intersect yung line of action niya sa iisang point, ang tawag daw dyan ay concurrent. Kaya nga concurrent, yung line of action niya nag-i-intersect. Hindi na niya kinakailangan mag-intersect physically, ano? Basta yung projection ng line of actions niya mag-intersect, ang tawag daw natin doon ay concurrent forces. Ang key takeaways natin dito, no? Vectors might not actually be in contact with a common point. Kahit yung kanya lang line of action. Yung projection ng line of action niya ay i-intersect sa isang point that is concurrent. Ano naman yung parallel coplanar force? Yung parallel coplanar force consists of two or more forces whose lines of action are all parallel. Ayan, katulad nito, ano? Sa mga beams. Yan, marami tayong mga parallel forces. Ito yung example ng parallel forces po natin. This is commonly the situation when simple beams are analyzed under gravity loads. Yun, yung sinasabi natin. This can be solved graphically but as combined most easily during algebraic methods. Okay, ano naman yung tinatawag natin ng non-concurrent and non-parallel? Ito yun. So itong mga puwersang ito, hindi siya parallel, hindi siya concurrent. Kumbaga parang kung saan-saan na siya pupupunta. Okay, so in cases of 3D, three-dimension, these systems are essentially a jumble of forces and take considerable care to resolve. Okay, so matinding pag-iingat daw ang kailangan natin dyan dahil nga napakarami ng mga puwersang mga nag-aak, Now, ano naman daw yung couple? Couple, the moment produced by two equal opposite and non-collinear forces. Kapag raw may dalawang force na equal yung magnitude, okay? Itong magnitude na to F, equal in magnitude but opposite in direction, which has a perpendicular distance d. Ngayon, yan daw dalawang forces na yan must be parallel. Pag sinabing parallel, no matter how far you extend them, it will never meet, no? So coupled daw po yan. Equal in magnitude but opposite in direction. Okay, the magnitude of the couple is independent of the distance, A, which locates the force with respect to the moment center O. Ayan. Kapag raw mayroon tayong given na couple, hindi na raw natin yan i-multiply sa lever arm or sa, for example, ito, halimbawa, nandito yung couple, moment couple, we do not need to multiply that by the perpendicular distance because it is independent. Mamaya makikita natin sa mga example natin yan. For the meantime, pakita ko lang sa inyo yung sense ng couple. Kapag meron tayong ganito na nakita sa mga beams and sa analysis natin mamaya, ang ibig sabihin niyan, clockwise couple or clockwise moment po yun. Okay. Pag naman ganito, counterclockwise po yung moment natin. So, ito, another representation to ng couple. Kung mapapansin mo, ang ikot niya is clockwise at dito counterclockwise. Ipapauna ko po sa inyo at papaulit-ulitin ko po, wag po tayong malilito doon sa rotational. Kakagaling lang natin doon sa dynamics. Galing tayo sa rotational motion, sa circular motion, which is counterclockwise is positive. Dito po sa statics, theory of equations, sa lahat po ng analysis ng mga structures, ang convention po, although hindi naman bawal na gamitin yung counterclockwise positive, pero ang convention po, clockwise positive. Yung directional, upward positive to the right positive. Okay? So, yan po yung ating mga takeaways. Okay, pag-aralan natin. Actually, hindi pag-aralan. Review natin. Ang sabi ni Newton, third law, to every action, there is an equal and opposite reaction. Okay, so kapag may reaction, kailangan malaman natin kung paano i-model yung action of the force nun. So, halimbawa, meron daw tayong belt. Okay, support natin ay belt at itinali natin dito or cable. So, ganito daw natin i-model yan. Ayan, ganito. Kapag belt. Ngayon, kapag meron daw tayong isang bagay na nag-contact with a smooth surface, meron lang daw siyang isang reaction na ganito. Kapag daw naman rough yung surface natin, Ngayon, may susupport daw niya ng pag ganito yung ating reaction. Meron tayong normal force at meron tayong frictional force. Ano? Ngayon, meron tayong tinatawag na roller support. Mamaya makikita nyo, ipapakita ko sa inyo kung ano yung mga klase ng support para hindi tayo maligaw pagdating natin sa statics. Okay. Kapag ka daw may roller support tayo, ang sinusuportahan lang daw ng roller is always away from the surface kung saan siya nakadikit. No? Katulad nito, it is away from the vertical kasi sa vertical siya nakadikit. Okay, upward lang yung roller natin. By the way, may mga roller na nakalagay sa tagiliran na ganyan, therefore, horizontal lang. Ano? Okay. Dito naman, freely sliding guides. O yan, yung mga guides natin na ganito, yung mga ganyan na nag-i-slide, o isa lang daw ang sinusupport niyan. Vertical lang din daw yung ating modeling dyan. Ano? Okay. Sa pin connection naman, ang pin connection may dalawang reaction lang tayo. Yung reaction natin which is Ry at Rx. So, the resultant can be resolved, no? Using Pythagorean theorem. Malalaman natin dito sa pin, the moment will be zero, no? Moment will be zero. So, susunod naman natin, yun yung fixed end support. Sa fixed end support natin, kumpleto yan. Meron, nakakabigay siya ng reaction sa vertical, meron din siyang reaction sa horizontal, at meron din siyang moment na ibibigay. Okay? So, yan yung tatandaan natin. Okay, eto naman, medyo familiar na kayo nito. If we have a body at may mga maliliit siyang weight na ganyan, nire-represent na lang natin siya by the isolated load na ganyan, no? Concentrated load na G nakalagay dyan, W which is equal to mg. Sa spring, ganun din. Nagkaroon na tayo ng discussion about springs before and we are representing it by F like this. Okay? So, hindi na bago sa atin ito. Okay, ito po yung ating gusto kong pagtuunan ninyo ng pansin kasi ito po tutuod yung ating mga pag-aaral sa mga darating na mga araw. Ito po yung tinatawag na types of support movement, yung movement they allow and reactions they offer. Ayan. Ano ba yung types of support? Movement they allow and reactions they offer. Pag roller daw, ito daw yung representation ng roller. Okay? Roller, simple figure. Ito yung figure niya. Ang inaalaw na movement daw ng roller ay horizontal at saka moment. Okay. Allowed, ano? Sa roller. So, anong reaction lang ino-offer niya? Vertical reaction lang pala. Or away. Away lang sa roller, no? Away from the surface. So, tandaan mo, isa lang ang ino-offer na reaction ng roller. Ito naman, hinge or pin. Kapag hinge, ito raw naman yung kanyang triangular na ganyan. Ganyan yung symbol niya, ano? Ano raw yung inaalaw niyang movement? Di moment lang daw ang inaalaw niyang movement. Ibig sabihin, kaya niyang kontrahen yung horizontal at yung vertical. So, meron siyang reaction na vertical at meron siyang reaction na horizontal. So, yan. Yan yung ating takeaway sa hinge. Now, dito naman tayo pumunta sa middle hinge. So, internal hinge, ang moment dyan, 0. Yun lang yung ibig sabihin yan. Kapag nagkaroon tayo ng moment dyan, that will be 0. Itong fixed support, ito pag-aralan natin. Yung fixed, ganito yan. Yan, mga naka-fix. Yan. representation niyan, figure. Hindi daw siya nag-allow ng vertical, hindi rin siya nag-allow ng horizontal, at hindi rin po pwede sa kanya ang iikot ka. Okay? So, kapag ka nasa support, magre-react daw yan ng vertical, may reaction ng horizontal, at may reaction din sa pag-ikot. So, therefore, yun po yung reaction na ibinibigay ng ating fixed support. So, yung middle natin, yung middle beam, okay, ang ibinibigay niya lang, ay ang horizontal. Okay? So, yung horizontal lang yung ang kanyang ina-allow na movement. Ngayon, pagtuunan natin ng pansin, kagaya nga nasabi kanina, roller supports, yung roller supports na yan are free to rotate and translate along the surface upon which the roller rests. O yan, yung sinasabi ko kanina. The surface can be horizontal, vertical, or slope at any angle. Basta ang laging tatandaan, it will be, lagyan natin na highlight, it will be, okay, away. Always a single force perpendicular and away from the surface. So, paano yan? Kapag ang roller mo ay, halimbawa, nakaganito, ganyan ang roller support mo, pwede ang puwersa mo pag ganyan, pag ang roller support mo ay pag ganito, o edi ang puwersa mo lang ay pataas. Minsan nga, patagilid yan patagilid yan. Roller, patagilid. O edi ang puwersa mo pa-incline din na gano'n. Away from the support. Okay? So, burahin natin to at pampapangit. Alright. Simple supports are idealized by some to be frictionless surface supports. This is correct in as much as the resulting reaction is always a single force that is perpendicular to and away from the surface. Yung mga simple support, isang roller at isang hinge. So, vertical lang yung kaya niyang bigyan ng reaction. Always away from the surface. Ano naman daw yung pin support? Yung pin support daw, it can resist both vertical and horizontal. Okay, kaya niyang i-resist yung vertical at saka yung horizontal load, but not the moment. Hindi niya kayang i-resist yung twisting. Okay? They will allow the structure member to rotate, but not to translate in any direction. Many connections are assumed to be pin connection even though they might resist a small amount of moment in reality. O totoo naman yun, kapag binigyan ka ng isang connection na pin, kaya niyang mag-resist ng moment pero hindi great amount of moment. Iikot at iikot yan pag malakas na yung pwersa. Okay. Okay, fixed supports. Fixed supports can resist vertical, horizontal, as well as moment. Okay, since they restrain both rotation and translation, they are known as rigid support. Yan yung mga nakikita natin sa mga beams and columns, mga fixed support yan. This means that the structure only needs one fixed support in order to be stable. Yung mga iba kasing structure natin, hindi na natin kinakailangan ng marami pang support, Sometimes, i-fix mo lang sa isang side, sufficiente na siya to support this structure. Kasi nga, yung daw ating fixed support na yan, meron ka ng vertical, meron ka pang horizontal, RH, meron ka pang RV, At meron ka pang tawad na moment which is always counter doon sa sinusuportahan niya. No? So yan, the representation of peak supports always includes two forces, horizontal, vertical, and moment. Ito na nga yung sinasabi ko kanina. No? Let us erase this kasi marami pang gagamit nito balang araw. Okay, so that is fixed support. Okay, yung pre-body diagram natin, ginagawa natin yan to represent the condition or the behavior of the forces, kung paano siya mag-a-act, no? Halimbawa, meron tayong simple thrust dito, okay, and may force na pa ganon, syempre, magkakaroon dito ng reaction. Kasi nga, for every action, there's an equal and opposite reaction. Kagaya nito, ito ay hinge at ito ay roller. Sa hinge, dalawa yon. So that will be vertical and horizontal. So yan yung ating nakikita ngayon, ano? Ngayon dito sa kabila, meron lang isa tayo pataas and then yun yung ating load P. I-represent natin yung FBT natin, ano? Ang tawag doon graphical representation of the forces. Okay, on a plane para mas madali nating ma-analyze yung ating mga sistema. Kagaya nito, meron tayong peaks and moments dito. So, sa FBD natin, ipakita natin na may moment dyan, may vertical at may horizontal, at ito na yung mga forces. So yan, pag-aralan po ninyo ito, yung pag-represent ng iba't ibang ano natin, yun lang ang key takeaways na nasabi ko na kanina, graphical representation of the behavior of the forces in a structure, how they will react, on what direction they will be going. Okay, punta naman tayo sa directional conventions. Kasi nga sariwang-sariwa pa tayo, galing lang tayo sa rotational motion, moment of inertia, sa mga circular motion, galing tayo dun sa ating mga centripetal, rotational kinetic energy. Doon kasi, counterclockwise is positive. Kasi nga doon, malaking kaugnayan natin doon sa tinatawag natin na quadrants. Ano? If this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Yung daw ating angle, sinusukat siya na counterclockwise from the x-axis, from here to here, counterclockwise yung theta. So sinabayan natin, kaya dapat positive din yung counterclockwise. Pero sa ano yun? Sa rotational po yun. Dito po sa atin sa statics at mga convention ng mga sa structures, ito po yung ating karaniwang convention. Although, pwede mo naman gawing baliktad, kaya lang, convention lang po ito. No? Upward forces will be considered positive. Okay? Upward forces are positive. Downward forces are negative. Counterclockwise are considered negative, and clockwise moments are considered positive. Tandaan nyo lang po yan, ano? Clockwise, positive. Counterclockwise, negative. Upward, positive. Downward is negative. May isa pa nga pala, hindi pa naisulat dito. So, sulat ko na lang ng ano-mano. To the right will be positive and to the left will be negative. Alright. So, with that, sa tingin ko, kaya nating mag-solve ng equation. Alam nyo na kung paano kumuha ng reaction, resultant forces. Alam nyo na rin yung mga support, types of support, anong ino-offer niya. Alam nyo na rin yung mga free body diagram, kung paano. So in the next slide, we start to solve problems. Okay, let us try to solve this problem. The uniform 100 kilogram I-beam is supported initially by its end rollers on the horizontal surface at A and B by means of the cable at C. It is desired to elevate end B to a position 3 meters above end A. Determine the required tension P, the reaction at A, and the angle theta made by the beam with the horizontal in the elevated position. Okay, just follow my cursor. We already pre-drawn this. Problem to save some time. If you are looking at my cursor here, this figure here is illustrating the problem, and this one is the pre-body diagram. So it is stated that there is this beam which is weighing 100 kilogram, and it is supported by its end rollers at A and B. It is to be pulled by a force P at point C, which is 2 meters away from point B. Okay. Now, of course, the weight of this beam will be acting on its center of gravity, which is somewhere here at 4 meters. Okay. Now, alam naman natin na roller yan, and we all learned that the roller, isa lang kapag roller support, isa lang ang sinusuportahan niya. It is always away from the surface kung saan siya ay nakakabit. So, mali po yung notion na kapag roller, vertical lang ang sinusuportahan niya. Ang true definition, it is only supporting a force that is away from the surface. Katulad nito, ang surface niya ay nasa vertical, therefore magkakaroon lang tayo ng vertical reaction. Minsan kasi may roller na nakakabit sa horizontal, therefore isa lang din, horizontal lang din yung reaction natin. We are clarifying things out dahil pag-elevate nyo sa statics at saka sa inyong theory of structures, napaka-basic po noon, kailangan nyo po sa foundation yun. Ano? So, ang roller din po ay nag-a-allow ng movement. So, kapag hinila mo ito, itong ping ito, hindi naman nire-restrict ng roller support ang movement, automatic iikot to. At siya ngayon ay aangat in such a way na magiging 3 meters. So, nandito na tayo sa kabila sa free body diagram. To every action, there's an equal and opposite reaction. That will be the reaction at A. That's Newton's third law of motion, action and reaction. So, may reaction at A tayo. And then may point of application of force natin is 6 meters away from A. That is P. And we are actually looking for that P na mag-aangat sa kanya ng 3 meters from this horizontal surface. And of course, this one, 100 kilogram yan, mass yan, no? So we have to multiply that by 9.81 para maging Newton. So I think by now we are ready to go. We are ready to solve the problem. Let us have some pen here. Okay, we say solution. Let me change my color. Okay, solution. We can sum up moments at point A and equate that to 0. Summation of moments at point A, and that will be equal to 0. We will be adopting the convention of statics, which is clockwise to be positive. Okay. Clockwise moments positive tayo sa statics. Wala na po tayo sa rotational motion. Ano? So, if we are summing up moments here, what we are seeing, we have 100 times 9.81. So, kwentahin na natin. Ano? So, 9.81 times 100, that will be 981. Ano? So, 981, magiging Newton na yan. Ano? 981 is the force. And what is the perpendicular distance? From here to here, that will be 4 meters. That is actually acting on the midspan. And that will produce a clockwise moment, therefore it is positive. And then we have a negative moment, which is P. And what is the perpendicular distance of that P from the axis of rotation A? That will be multiplied by 6. And that is equal to 0. Okay, if we transpose P to the other side of the equation, we have P times 6. That will be positive, and that will be equal to positive 984.81 multiplied by 4. Okay, what is the unit of this one? This one is in Newton and meter. O we divide both sides of the equation by 6 meters. Meter din to. So, makakancel man yan, ano? Cancel yung meter. Divide by 6 meters dito sa kabila. So, we can cancel meters and the result will be in newtons. That will be in newtons. So, let us try to divide 981 divided by 6. 981 times 4 divided by 6. 654. So we have 654 newtons. So there you have it. That is your answer for P. Ngayon, the reaction. Okay, the reaction at A. So let us solve for the reaction. We apply the second condition of equilibrium. We say summation of forces. I am in the bottom left now. Summation of forces at y is equal to 0. And that will be upward positive. We considered upward forces positive as our convention. Mga CE conventions yan, ano? So therefore, what are the upward forces? We have R. And then we have plus P. But what is P? P is 654. 654. And then, what else? We have 981 to be negative 981 will be the weight. And that will be equal to 0. So if we transpose everything on the other side, we have 654 minus 981, positive 327. So we have here R to be equal to 981. Pakita natin para hindi mabigla. Minus 654. Okay. And that is 327 sa ating calculator. Pasensya na ha, hindi ko magamit itong ating virtual calculator kasi nasa PowerPoint po tayo ngayon. Kaya dito na lang tayo sa calculator natin na ito bumabase. Now, so, ano pa yung tinatanong sa atin? We have theta. We are asked to find theta. Yung theta, readily we can solve for theta because given naman ito, given itong ating hypotenuse at given naman yung ating opposite. Sabihin natin sine of theta is equal to the opposite side over the hypotenuse side. Okay? That will be over the hypotenuse side. Therefore, we will be having theta as the arc sine of opposite over hypotenuse. Okay, opposite over hypotenuse. Alright, so theta natin, what is our opposite side? Opposite is 3. That will be 3 over 8. That will be 8. And we have arc sine. Arc sine of 3 over 8. So there you have it. Arc sine of 3 over 8. That will be your theta. So what will be our theta? 3 over 8. Inverse sine of the answer. So that is 22 degrees, 1 minute, 27.53 seconds. So dito ko na lang ilagay, ano? Theta is equal to arc sine of, tinapos po tayo ng lugar, kaya 3 over 8. Dito na lang natin pagtinuin. And then that will be equal to 22 degrees, 1 minute, 27.53 seconds. Alright, we have here a very simple example of a statics problem, and siguro dito tayo magbibigay ng maraming sample problems kasi ito nga yung kumbaga climax ng Physics 1. Yung lahat ng pinag-aralan natin when we are in the resultant, the reaction, Newton's first law, Newton's second law, lahat ng application nun dito na. Highlights po ito ng Physics 1, which is mechanics. At namang Physics 2, dadako tayo doon, electromag po yun. So, siguro dito natin bigyan, magbigay siguro ako ng mga 8 or 9 na sample problems para mas maganda yung ating foundation. Okay? I hope with this, pasensya na po at talagang mouse lamang po talaga ang gamit natin. Hindi pa po nadating yung aking order na right pad. Sabi ng Shopee, papadala na ako. Anyways, I hope this will help. Okay, let us try to solve another problem. Problem number 2. Determine the magnitude T of the tension in the supporting cable and the magnitude of the force on the pin at A for the jib crane shown. The beam AB is a standard 0.5 meter I-beam with a mass of 95 kilogram per meter of length. Okay, we have pre-illustrated this problem, and we have drawn this illustration, and this is the pre-body diagram. Meron daw tayong beam at given siya ng mass per meter of length. Okay? Now, meron daw siyang support at A, which is pin support. Ngayon, alam naman natin na ang pin support ay vertical at horizontal lang, ano? A sub Y and A sub X, wala siyang moment. So, ito yung ating reactions na makukuha, no? Now, this tension T is inclined 25 degrees with respect to the horizontal. At meron daw siyang load na 10 kilonewton, 1.5 meter from the end B, which is located here. Okay? Ngayon, Saan naman nakuha itong 4.66 kilonewton na yan, ano? Yan yung ipapaalala ko sa inyo mamaya at yan yung noon ko pang idinidiscuss sa inyo nung tayo nasa torque. Now, given din tayo ng 0.25 meters kasi nga 0.5 daw yung lalim ng biga, dito lang tayo mag-moment sa gitna. Malaking epekto niyan, ano? Magkakaroon niya ng lever arm or perpendicular distance pag nag-moment tayo, which will be 0.25. Okay, meron pang isa, yun daw clearance ng pin connection from the edge of the beam will be 0.12. Ipakita nga natin yung mga yan, ano? So, ito, 0.12, itong clearance na to magmula rito hanggang dito. Yan. Kasi nga ito yung pin connection natin. At itong 0.25 na to, that will be half of this 0.5. Okay. So, we are now ready. Ngayon, kailangan natin munang pag-usapan itong 95 kg per meter na to. No? Ito yung sinasabi ko sa inyo na mag-iingat kayo lagi kapag binibigyan kayo ng W. Minsan iba-iba ang binibigay. Kanina W binigay katulad sa first problem. Ngayon naman W yun na. Tapos ang pet malo dyan, kilograms pa, no? So, hindi lang siya W Newton per meter, kilogram per meter pa, no? So, WU. Weight per unit length. Iba pa rin yung weight per unit volume, ano? Unit weight yun. Dito, weight per unit length. Paano gagawin natin? Di yan W yan, convert natin para maging W. Maging Newton siya or kilonewton. Paano natin gagawin? So, i-multiply natin to sa 9. Ito, i-multiply natin sa 9.81 meter per second squared. Hindi magiging Newton na siya, no? Okay. May per meter pa yan. I-multiply pa natin sa 5 meters, which is total length. Makakancel yung meter, yun ang lalabasan. So, let us try. W is equal to 95 kilogram per meter multiplied by 9.81 meter per second squared times 5. Ito raw yung computation na lalabas. So, yan daw computation na yan. Ang sagot daw ay 4.66 kilonewton. O bakit naman naging kilonewton yun, sir? Slow motion natin, ano? Kailangan natin ipakita dahan-dahan. Ito raw kasing meter na to. At saka itong meter na to, magka-cancel siya with each other. Yan ang istorya niyan. Ngayon, ang matitira daw itong berde, itong kilogram at saka meter per second squared. Yan daw ang kwento dyan, ano? Ito ang kwento dyan, ang natira si Newton. Nung natira si Newton, nagpunta siya doon, kailangan natin siya i-convert sa kilonewton. Bakit? Kasi itong 10 kilonewton para magkaroon tayo ng tinatawag na consistency of units. O i-divide natin sa 1,000 kaya naging 4.66 kilonewton. So, alam na natin ang istorya nitong 4.66 kilonewton na to, no? O, yan. Ngayon, pwede na tayong mag-sum up ng moments. Alam naman natin na kapag pin, dalawa lang, ano? Vertical at horizontal lang ang reaction. Wala siyang moment, ano? Uulitin ko. So, we can sum up moments at point A and equate that to 0 so we can get T. So, let us try that. Summation of moments at point A is equal to 0. Clockwise moments to be positive. What are the forces that will rotate in a clockwise manner? The forces that will rotate in a clockwise manner is etong 4.66 na to, clockwise yan. Etong 10, clockwise. Eto namang T, counterclockwise, T sub X and T sub Y. Bago tayo pumalaot, ano? Kailangan natin ipakita na ito ay T sub X, I have pre-drawn here, at ito ay T sub Y. Ngayon, alam naman natin na kapag may inclined force tayo, we can resolve it into its components, which is T sub X and T sub Y. Okay, now, we are ready to sum up moments. Unahin na natin yung T dahil yun yung unknown. So uh, we say here that negative T cosine 25 times 0.25. Ano naman yung istorya niyan? Itong negative thing to, bakit negative? Because yan yung T sub X. Counterclockwise ang ikot, no? Counterclockwise ang ikot, kaya negative. Bakit T cosine 25? Kasi T sub X nga yan, that is adjacent to the given angle. Kaya cosine. And bakit 0.25? Kasi yun yung perpendicular distance niya. Ayun. Kalahati ng 0.5, 0.25. Iikot siyang pa ganyan. That is the story behind negative T sub X cosine 25. Ano naman po itong negative T sub Y na yan? Negative T sine 25. Ayun, yun yung T sub Y. T sub Y is T sine 25. Bakit negative? Counterclockwise. Bakit 5 minus 0.12? Kasi nga, magmula dito hanggang dun sa dulo, is 5. Meron tayong clearance para dun sa pin na 0.12. I-minus mo yun yung lever arm or yung perpendicular distance. O yung tawag na iba dyan, moment arm. O lahat na ng klaseng tawag. Sinabi ko na rin po sa inyo, no? Kahit alin po ron, pare-parehas lang yon. Okay. Ngayon, ano naman itong 10 na to? Anong story ng 10? Yan yung 10 na ito dun sa hook. It will be a clockwise movement. And saan naman ako yung 5? O edi yung 5, magmula rito hanggang dine, 5. Kailangan natin bumawas ng 1.5 dahil nandun lang yung hook. Bakit pa natin kailangan bawasin yung 0.12? Kasi nga yun yung clearance dun sa pin. So, maliwanag tayo din ano? Tapos na po ang istorya ng 10. Ito naman dini naman tayo. Ano naman ang istorya nitong 4.66? 4.66 will create a clockwise movement. That's why that is positive. Kung positive yan, clockwise yan, no? Multiply natin sa 2.5. Bakit? Kasi nasa center of gravity po yan. Yung weight na yan, laging center of gravity. Bakit kailangan bawasin yung 0.12? Kasi nga hindi tayo nakasagad sa dulo, nandito lang tayo. So, maliwanag na po tayo na. Diyan iyan lahat ng yan ay equal to 0. Okay, hindi lang nakita kasi medyo kapusan tayo ng space. Ngayon, ayan, the rest will be computation. Ito raw, ito raw ang equivalent, negative 0.2265t. Are daw naman, negative 2.0623t. At ito, positive 33.8 at are daw, positive 11.090. So, ang lalabas daw dyan na sagot ay T is equal to 19.6128 kilonewton. Bakit nakalagay dyan counterclockwise ang T? So, ang T niyan counterclockwise kasi nga ang assumption natin sa T ay paganyan. So, tama. Ang T natin pataas at papunta dito. Okay? To the left and pataas. So, yan po yung ating annotation dyan. Yung iba naman, ang sinasabi dyan, nilalagyan na lang ng ganito. Okay, paganyan. Pasibat na paganyan. So, ibig sabihin, paganyan yung ating T. Northwest. Okay. So, Paano naman natin kukunin yung resultant? So to get the resultant dito sa AY at dito sa AX, we simply sum up forces at X, makukuha natin yung AX, and sum up forces at Y, makukuha natin yung AY. Therefore, let us try to do it. Summation of forces at X is equal to 0. To the right, positive. What are the forces acting to the right? The only force that is acting to the right is A sub X. And there's no other force that is acting to the right. The other forces is acting to the left, and that is a solitary force, that is T sub X. Therefore, we can say A sub X minus T cosine 25. Ano yung T cosine 25? Ito yung T sub X. Ano? Ito, T cosine 25. Minus kasi to the left. Therefore, R sub X is equal to 19.61 cosine 25. Ang computation daw niyan ay naging 17.77 kilonewton to the right. Bakit to the right? Kasi positive yung lumabas na sagot. Ang assumption natin dito to the right, tama yung assumption natin, ano? Tama yung ating assumption. Ayun. So, ano naman ngayon yung ano natin? Ano naman yung ating susunod? Ang susunod naman natin will be summation of forces to the uh, summation of forces at vertical. So summation of forces at vertical is equal to 0, upward to be positive. What are the forces acting upward? So ang mga puwersang pataas, A sub Y, we assume that that is upward, and T sub Y. T sub Y, automatic upward yan. Bit-bit niyan pa ganito, no? Ang assumption lang natin dito, this is upward. And kalaban nila C10 at saka C4.6. So therefore, we can say A sub Y plus T sine 25, that is T sub Y, minus 4.6 minus 10 is equal to 0. O yan na yun, ha? Pero teka, kailangan pa natin isolve yung A. Ano yung resultant ng A? So let us try to solve for the resultant A. A, edi Pythagorean theorem lang, is equal to the square root of ax squared plus ay squared. Ngayon, hindi lang makita rito, no? Hindi lang makita rito yung ating sagot kasi nakokoberan itong ating camera. Tingnan natin, patayin yung camera. So there you have it. 18.88. Ngayon, kailangan lang natin lagyan to ng square root po ito, no? Medyo mahirap lang. Yan. Okay. Let us try to solve this new problem. Problem number 3, a 500 kilogram uniform beam is subjected to the three external loads shown. Compute the reactions at the support point O. The XY plane is vertical. Okay. So, yung XY plane daw natin, vertical. Ito yung given natin. If you will try to follow my cursor, this is the given figure in the problem. Now, it is supported by a fixed support at the left end. So, it has a load of 1.4 kilonewton upwards, 1.2 meter from the 1.2 meter from the support, and it has a moment load at 3 meters from the support, point B, 15 kilonewton meter. Now we have a concentrated load here, which is called an inclined load that is making 30 degrees with the vertical, that is 3 kilonewton. The application of that load is how many meters? That is 1.23, 4.8 meters from the support. So, dito naman sa kaliwa, kung mapapansin nyo, nagawa ako ng free body diagram. Ano? Of course, the beam, may binigay tayong weight that is 500 kilogram. Yung beam na yan is subjected to a weight. Ito yung weight na yon. Lagi yung weight na yan nasa center of gravity. So, tinansya ko lang, siguro ito is 2.4 meter. No? Not to scale po ang drawing. Now, meron tayong counterclockwise moment load here at point B. Tapos, meron tayong inclined load, concentrated load, which we can resolve to its components. Ayan, dinrawing ko na. Yung T sub Y, that is T cosine of 30. Pangitang-pangitan na po dahil ito'y 30, ito yung T sub Y, that is adjacent to the angle, that's why T sub Y is cosine of 30. Buksan ko lang ng ilaw, ha? Alright. So, T sub Y cosine 30. Now, here, ito naman, that is opposite the 30-degree angle. So, we have T sine 30 and T is equal to 3. So, ito ay 3 sine 30. Gawin nga natin 3 sine 30 to. This will be 3 cosine of 30 and ito ay 3 sine 30. Okay. So, dito naman sa reaction, when we go to the reaction, makikita mo rito, meron ditong, syempre, ang reaction natin ay fix. Ang fix, tatlo ang kanyang sinusuportahan. Magkakaroon siya ng reaction at Y, meron siyang reaction at X, at meron din siyang moment. Okay? At ang moment sa support, it is always acting counter to the load. No? Kina-counter niya yung load. So kung ang load ay clockwise, in this case, the loading is tend to rotate the whole structure clockwise, then our reaction to that moment will be counterclockwise. I-assume natin yan. Nevertheless, kapag ka naman lumabas siya na talagang counterclockwise, that will be negative. Okay, now, so we are ready to solve the problem. Ngayon, pag-usapan muna natin yung weight nitong beam na to, no? Itong beam na to ay may 500 kilograms daw. So yung 500 kilograms na yan, minultiply ko sa 9.81, magkakaroon ako ng newton. Dinivide ko sa 1,000, so meron tayong 4.9 kilonewton. Ngayon naman, we can sum up moments now, no? By the way, yung load na yon, W, 4.9, dito mapapapunta. Okay? So, kuha tayo ng guide. Itong 4.9 na to, dito yan papasok. Yan, sa W yan. Which is 2.4 meters from the support. Okay. So, sana maliwanag tayo, no? Summation of forces at Y is equal to 0, upward to be positive. So, upward forces natin will be positive. What will be the forces acting upward? So, the forces acting upward will be 1.4. Ano ba? Wala na, no? So, 1.4 lang, tsaka yung Ry. Therefore, we can say Ry, which is positive, and plus 1.4, which is positive because that is upward. Tapos minus the weight. Yung weight natin which is 4.9 kilonewton. Tapos ibabawas pa natin yung t sub y. Yung t sub y, 3 cosine 30. Okay. Therefore, we have, if we transpose everything to the other side of the equation, ry will remain at the left side. Therefore, ry, which is positive, negative 4.9 will become positive because we're transposing to the other side of the equation. And then we will have positive 2.59, that is 3 cosine 30. And then this positive will become negative 1.4. We will have 6.09 as our reaction at y. Okay? ROY ang tawag natin yan. So, let us continue. Pwede tayong mag-sum ng forces dito para makuha yung ating Rx. Edi, gawin natin yung para kunin natin yung Rx. Therefore, we have summation of forces at x is equal to 0 because this is in equilibrium. Remember, we are in static equilibrium. So therefore, summation of forces at x and y will be equal to 0, and also summation of moment. Okay. Therefore, this one is to the right. To the right will be positive. Yun yung ating convention. What are the forces acting to the right? The forces that is acting to the right is the reaction at ROB. That is the force, it's the only force acting to the right. And the other one is the load, which is subtended by this 3 kilonewton. Therefore, we have Rx, which is to the right, Rx is to the right, minus 3 sine 30, which is to the left. And that is equal to 0. Therefore, Rx is equal to 3 sine 30, and that is equal to 1.5 kilonewton. I hope maliwanag tayo ha. Dito, nag-sum tayo ng forces, and we equate that to 0. That's the first condition of static equilibrium. The second condition, you sum up forces at x and equate that to 0. And yun yung second condition. And the third condition, we sum up moments at the support and we equate that to 0. And that will be our third condition of static equilibrium. Now, tandaan natin dito sa hinge or sa fix. This is a fixed support. Sa fixed support, meron siyang moment. Okay? Tawagin natin siyang M sub O, no? If we sum up moments dito, that will be equal to M sub O. Or we can say we can sum up moments at O and equate that to 0. We still have to assume that this is counterclockwise, and we still have to add that one. So pwedeng sabihin natin, baka kasi pagdating nyo sa higher years, makakita nyo na summation of forces at this point is equal to M sub O na rin kagad, ano? Tama yun, but that is just a shortcut. Ang totoo niyan, sa basic foundation, summation of forces at this point is equal to 0, and then you still have to add that moment here. Okay, let us do that. Summation of force of moments at O is equal to 0. Clockwise positive. We have, what are the clockwise moments? So we are summing up moments here. So we are finding this W. This will produce a clockwise moment. W multiplied by 2.4. So that is positive. And what are the other forces that will cause clockwise moment? Eh di itong 3 cosine 30 to, no? Kasi pag ikot niya pa, clockwise siya. 3 cosine 30, eh di ito yun. Tapos anong perpendicular distance niya? That will be 1.8 plus 1.8 That is 3.6. That is 4.8. 4.8. Okay. Now, meron pa ba tayong ibang nakikitang clockwise movement? Kung wala na, how about this one, sir? Tingin ko hindi siya magpo-produce ng movement kasi coaxial siya, no? So, ibig sabihin, axial siya, ibig sabihin, it is in line with the axis of rotation. Now, meron pa tayong ibang movements. Ito, yung 14.4 kilonewton na to, anong mapoproduce nito? It will produce a counterclockwise moment if we are rotating at this, if this is our axis of rotation. So therefore, negative 1.4 times what is the perpendicular distance? 1.2. Now, meron pa ba? Ito yung moment na yon. So, itong moment na to is actually acting counterclockwise. That is 15. Kailangan pa ba natin, sir, i-multiply yan sa perpendicular distance? Hindi po kasi moment na po siya. Kilonewton meter na yan. You do not need to multiply this to the lever arm because this is a moment. That is a moment couple actually kapag binarya natin. Kanina may napag-usapan na rin tayo sa ating ibang slide, earlier slide, yung tungkol sa couple, ano? At alam na rin natin yung reaction ng moment. So that is the negative 15. Why negative? Because it is acting counterclockwise. And then, yon yung M sub O yon. We still have to add it. M sub O minus kasi ang assumption natin counterclockwise. Okay. So I hope maliwanag na po, ano? And then everything will be computation. So we have M sub O, if we transpose this M sub O to the other side of the equation, that becomes positive, yun na yun. And ito, hindi mababago yung lahat ng sign niya. It will be remain in the left. Okay? So M sub O will transfer to the right, and then we rewrite that. M sub O is equal to 4.9 times 2.4, 11.76 daw yon. Tapos ito raw, 12.47. Ito naman, 1.68. And ito, 15. So therefore, 7.55 kilonewton meter. So, I hope naliwanagan tayo, no? Actually, this is statics na rin naman, pero subject natin sa physics, wala tayong magagawa kung hindi daanan pa rin po. Pero maraming kayong dadaanan nito pagdating ninyo sa theory of structures and statics. Okay, we will go to another problem.